Captain Peter Cutsey, we're in the hold at pair of at 6,500. And QNH has been set. We have now been cleared for the localizer Zulu to runway 18, circling around runway 36. Configure now for flap 5. Flaps 1. Set flaps 1 speed. And we'll exit hold, execute and activate on, and we're reminded to set the MCP altitude. We're going to come up to the top of descent, and we'll do that shortly. We'll clear that message. And flaps 5, set flaps 5 speed. Incidentally, the descent and approach procedures have been complete, and the descent and approach checklists have been complete. Flaps 5 speed set. We drew a ring around, a 2 nautical mile ring around the top of descent point where we will begin the 7 items. Set the MDA, RMP, AMP, VNAV path, gear down, flaps 15, speed brakes armed, open the speed window, and set the flaps 15 speed. So we will do all of that. There's the top of descent prompt there. We can see it on screen. We're back at flaps 5 speed. And we'll just confirm our flaps 40 UF is 134 set. And as a reminder, all conditions are ISA, 13.5 degrees at the field for the temperature, and 1013 is the altimeter on the QNH, and the surface wind is calm. Active waypoint at Charlie Yankee 131 is the point that we designed. That overlies the actual real point for the approach. All right, let's begin the 8 items. We'll set the MDA first, which is the 1900 rounded. VNAV path, RMP, AMP check, gear down, flaps 15, and flaps 15 speed. Open the speed window and set the flaps 15 speed. That is flaps. And speed brakes armed. Bring the heading bug around. We are LNAV now. We can bring the heading bug around to the runway. We're in VNAV path, and we're on the nav performance scale, and we've started down. And we've also have the vertical path on the nav display. Heading bug should reflect the same as the course. Let's have a look outside. There's LEC Aubin in flaps 40. And let's set the ref 40 plus 5. We're on vertical path, then we're on the lateral path. There is LEC Aubin, I should say, and there is a runway in front of us. There's a rate of descent. Radio altimeter alive, And we will go to the center display for the VSD. Now the radio altimeter isn't because of the terrain underneath us. And we will get it again soon as we come up over this point here. Let's have a look outside. Our rate of descent is increasing. And as we can see here, our vertical deviation is now rejoining back to where we should be. There's the nav performance scale. Good rate of descent to follow that very steep path. Vertical deviation, we are coming back. Now we're coming back to our path. Speed is set. The landing procedure and the landing check have been completed. And we are at flaps 40. And flaps 40, rev 40 plus 5 set. $1,900, rounded up to 1,900. 1880 is our minimum. And there's our minimum set on our barrel reminder. Still on path, looking good outside. We'll activate the sound now so we can hear the alerts. And remember that if we're visually clear of mountainous terrain, we don't have to execute the escape maneuver. Stabilizer is trimming. We'd expect that because of changing our attitude. It's not running away. Good rate of descent. Radio altimeter alive. Radio altimeter, barometric altimeter, VSD checked. We're on path. 1660 radio altimeter. 2440 barometric altimeter checks. On recent site, we'll continue with the approach. There is the terrain on the VSD, and you can see it in front of us. Approaching minimum. Continue. Set our heading bug to commensurate with our track.
Approaching minimums.
Altitude required. Set a lower altitude here. The second stage descent. ENAV path. We are in. Remember on the legs page, we've got the point delta at 1880 or above. That should put us on the property.
Terrain.
1,000.
Terrain.
I paused the video and I put the sound back on so you can hear my voice clearer. Remember we discussed before, if you get a terrain and you're in visual conditions and you know you're clear of terrain, then you may carry on. You'll find that at this airport and at airports in Austria, in mountainous areas, you can expect that. And normally on the approach chart, they would have a comment that says something to that effect. So we're going to carry on because we are clear and we expect to hear what we are hearing.
Terrain.
The altimeter at 940 feet. ASD confirms that we're okay. Barometric altimeter at 1900. That is a true altitude. The temperature of the field is ISA. So the sound is off, so you can hear my voice in this last bit. If you notice, we have several waypoints in the radius to fix arc. We talked about that before. In the airplane, it would be a constant arc. Landing check is complete. The missed approach altitude hasn't been set yet. We don't want to start down until we are by point delta, which will put us on the 4-degree poppy. And what we'll do is we'll freeze the airplane when we get close to that point. In real life, once you see the runway and the poppy is usable, you would actually complete the approach. Well, there's the runway. Now let's just freeze the simulator here. And let's have a look at a night scene. So slightly high, and we would actually, there's one red and 3 whites, and we're regaining our path. We would disconnect the AFDS systems at this point and carry on visually. So here we are just leaving it engaged so you can have a look at it, but we'll stop it here and we would actually continue this approach visually. If we continued here and followed the path, you'll find out that the aircraft would actually regain the path and we would be fine. But as I mentioned before, we would actually disconnect the entire AFDS systems once we're visual, and so that we can do this approach manually. And we're looking good. We're still connected, and this is how accurate all of this wonderful system is. We'll stop it there, and welcome to the future. And you need this approach in your airplane so that you can have a safe operation, and it'll give you the flexibility of going to different single runway airports around the world. Thanks for watching.